Okay, for today we're going to talk about geometry. So the last couple of weeks we have been covering some of the basics about SQL and getting data in and out, but we have not really dealt with the geometry yet. So today I want to go through how geometry is handled in DuckDB, the spatial extension, and also how to visualize the data. Because so far we have only been seeing the CSV rows and columns. But because those are vector data, we can actually visualize them once you get the data out. So before getting into visualization, first we want to cover how you deal with some of the geometry. So here I already created some sample data. Activate this one. So for this file here, nyc data.db.zip. So this one is actually a DuckDB file. So I already created DuckDB, and then I already loaded a couple files, tables in there, so that you don't have to create manually. So what we can do is just simply download this file, and then if you open here, you should be able to see where is it? Yeah, this one, nyc data.db. So this is a DuckDB database that I already created. And so next, let's connect to the database and also load the spatial extension. So we used to be familiar with this one by now. And then we can use the show tables to show what's in there, right? So this is similar if you use dbeaver to view the table, or you can do it one by one. So similarly, right, you show all the table. Sometimes you don't know what's in there. But once you know the name of the table, then you can like show a specific table. And then I can just type con.sql, right? What single quote from, and then just the name of the table. From the table, then you should be able to see the content of the table, right? So here inside this database, you'll be able to see this column here, point. This is the NYC subway stations, the point file, the shape file. So I load it in there and then save it as a table. So now you can see the text in here. So what we're trying to do is to like how do you sometimes handle this column and how do you export the data out so that you can visualize the data directly. But for now, let's forget about this one because I already created the data for you. But if you want to start from scratch, sometimes you want to create this vector data on your own, you can also do that. So here, look at this whole block here, SQL. So we're going to create an empty, a new table called samples. And then, so create or replace table, right? If the table doesn't exist, we're going to create one. And this is the name of the table. After that, parentheses. So this one basically is the columns. Kind of like you are creating a new shapefile using ArcGIS. You create a point or line or polling or whatever. And once you create, you can also specify how many columns do you want, what's the name of the column, and so the data type. So what we're trying to do here is to create a samples column with a samples table with two columns. The first one is called name, and varchar basically is the character. So it's kind of like in Python, it's called str, the string. And the second one called GOM is a geometry type. The geometry type comes from the spatial extension. So if you didn't load the extension, you won't be able to use this one. But you can use varchar, integer, double, date, something like that. So each column has a type. So what I'm trying to do is create an empty table, and I have two empty columns, name and geometry. Okay, so the name is just a string, and then the geometry is GOM is a geometry column. Once you have the empty table, then you can start insert rows into the table. Kind of like in QGIS, you create an empty table and then you start doing the editing. You draw a polygon and then you're going to add things to it. So let's look at this one here. Insert into the table name and then values. And after the value, you can pass in a list of tuples. So you can see from here, we have created a table and then we insert. Pay attention here, point and then comma, and then this is the geometry. So if you see this one, st geometry from text, and then something like this. So if you are wondering where does it come from, where this function come from, if you go to the DuckDB website, and then documentation, extension, then the spatial extension. So it comes from here. So this is the geometry type, right? The second column we're creating is this one. So how to actually create geometry? You can use some of these functions. So what we're using is AST from, where is it, from text, AST geometry from text, and we're just passing a string. A string is like point, parentheses, and then put something in there. So these are some of the ways you can create a geometry, and it so depends on the different types. If you already have other geometry, you can also convert it to a GeoJSON or something else. But what we're trying to do here is just to create a geometry column, converting from string to geometry. So let me come back to this one here. All right, so look at it closely one more time, right? This is a parenthesis, it's a tuple inside. The tuple has two items. The first item is just, this is a text. So basically this one corresponds to the name. Essentially, you have a script file, and then the first column is like name, and then the name like point line. It doesn't have to be the exact point. You can choose whatever name, like subway or university, whatever. It's just a random name. And then this one is important. So this one you do need to follow exactly what you need to provide. So AST geometry from text, and then you see here parentheses within there, single quotes, point, and then parentheses, X and Y. Okay, so in here is X is longitude, X, right, horizontal, vertical, X and Y. So what this one is doing is we are creating a point of what, 100-degree longitude, 40-degree latitude. And so this point is represented by a string, and we convert the string to geometry so that you can match this geometry type. Understand? So basically, this is how geometry is represented. This is called well-known text, for example. So it's creating this one from here. Similarly, right, we have creating a line. Again, this name doesn't matter. You can use whatever name, but this one you do need to follow the convention here. AST geometry from text, and then this is called line string, and then XY, 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 XY. Okay, so line, longitude, latitude, for the first point, and then comma, longitude, latitude, longitude, latitude. So what this is doing is we are creating a line with how many points? 4 points. Join it together. Similarly, you can do polygon, like polygon, and also the line. You can see the first one, the last one, join together. Later, we can visualize this if you want to. So it's just showing you how this was created, and also you can polygon with holes. So basically, you have to have two components here. The first one is like external, and the second one is like interior, exterior, interior. I think I have an example here later showing you how it was done, like something like this in here. So how this was actually represented in GIS is like using the point, and this is the exterior coordinates. If you have something internal, you're going to separate it by comma. So this is what this one looks like in here. The first point, the exterior, and then the interior. But you can have multiple holes if you want to. And the last one is called geometry collection. So these are basically all the OGC standards. What kind of type? So it would be line, a point, multi-point, line string, multiple line string, polygon, multiple polygon, and also geometry collection. So these are the common data types that DuckDB can understand. So basically what GDAL can understand. And so creating a table, we insert 5 records, right? Point, line, polygon, blah, blah. You can add more if you want to. I can, like, for example, here, copy this one. Make sure you don't put the semicolon at the end. If you have more, I'm going to have comma. And then from here, I can do the same thing. Right? And this one I can change maybe to 120, -40, something like that. And lastly, semicolon. And by run this one, can you see the points? So right now, basically, we're creating like vector data with columns, string, but you can add more. So if you have multiple columns, for example, I can say name, age, whatever. It's just like, think about just like a CSV, but there's a column in there indicating geometry. And how to indicate the geometry is using these functions. Otherwise, if you just put in a string, it's not a geometry. It's just plain text. There's no geometry. Although right now it's showing here because the spatial extension can understand it. So this is simply how you create the geometry. And then from there, when you print it out, sometimes if it is like binary, you cannot see it. You can also use this st underscore as text. So kind of like when you're trying to, let me see if it works, right? Let's do this one. How about we export this data? Assume this is the the vector data that you created. So now we want to maybe export this one as a CSV. So how do we export it as a CSV? Remember? Copy, and then you can just, okay, yeah, it's pretty intelligent. I don't even need to type. So here I'm going to remove the last one. Double quotes. All right, we're exporting this one as a CSV, and let's see what happened. Right, run it, and come here. It should have a samples.csv. Here. Okay. So you see here the last one is actually kind of like a string. Some of those have the double quotes, some of those doesn't have the double quotes. But if you use sometimes the data they export is going to have like binary strings in here that you cannot understand. This one is okay, so you can just export this one. But like I said, once you export as a CSV, these right now these are plain text. If you open in GIS, you cannot understand that it's a vector data. It's just a CSV. So there is no spatial information anymore. So besides using this way, you can also use this one, AST as text, basically converting the geometry to text. Ideally, these two should be the same. So if I run this one, these two columns are the same as this when you directly print it out. The reason you want this is sometimes if the geometry is like a secret, you want to convert to plain text, then you can use this one. Again, all the functions come from here. So make sure that you sometimes you might want to come here to search to see what it is. So I can say here as text. Look at this one, geometry conversion, right? So earlier we create the geometry, but we can also convert the geometry from geometry to text. So this one is passing the geometry, convert this one to text, and the result will be a string. So this is exactly what this one in here. Of course, you don't need to do that. You can just say okay, GOM. It looks the same, but the only issue is that for some vector data, if you don't explicitly convert to text, if you remember the Parquet file that we in the last lecture, right? It's just like 1010. You cannot read it. Make sense? So let me here. Maybe I can show you like where is it? Somewhere last time. I already don't have time to go through it. Just finished it. But I will show you examples later when we have time. So this is the converted to text, but you can also copy it as GeoJSON because this is the one that we created. We know it has a geometry column, and we can just convert this one to a GeoJSON and then use the spatial extension driver GeoJSON. Maybe run it. So now we should have samples of GeoJSON. If you open it, it's going to convert something like this. Okay, and this one you can open using GeoPandas. You can use others. So I can show you here, right? So now we have this GeoJSON. Then if you want to see it, you can either use DeepMap or you can use GeoPandas. So I'm going to just use GeoPandas to show you how to do it. Import GeoPandas as GPT, and then I can just GTA. Okay, I didn't install it. Too bad. So let me try very quickly. Honda activate. What's that? Geo, and then pip install GeoPandas. Yeah, try to install it. Later this lecture, we're going to also try to use it. Like I said, I don't use Windows computer, so I only use it when I'm teaching. So some of the packages are not always up to date. And so GeoPandas allows you to read any vector data, and then you can just click one line of code. You can visualize the vector data. So what we're going to do here, after it's done, then we can quickly show you, for example, that couple vector data that we created. We can visualize that. Hopefully, okay, it's done. And too bad I need to restart the kernel. So now, run this again. Hopefully no errors. Yeah. Oh, okay. So by the way, so if you're exporting data from DuckDB, for CSV and JSON file and Parquet file, you will automatically override. But for vector data, if the file exists, sometimes it will not allow you. So you need to manually delete the file. Oh, it works now. Anyway, so here I'm going to import this one, and then I'm going to read this one equal to, okay, so smart. So GDF. I'm not sure if this works or not. Yeah, GeoJSON. Yeah, anyway, this works. So what we're doing here, we can just gtf.explore. There might be some missing dependency we need to install. Oh, no? Yeah, that's what I'm saying. You need to install map classify. Did I install leaf map? Volume should be in there. So probably just this one, map classify. So again, so annoying. So let's install one more time. Conda activate geo. Hit install map classify. So this one basically doing all the color stuff, doing creating maps, but the GeoPanda's explore function is quite handy because you can visualize basically read any vector data and you just plot it. But keep in mind, it's good only for small data set. If your vector data is like 100 megabyte, it's probably not going to work. It's going to be very slow. I did have some other ways we talk about later this course to show you how to visualize large vector data set, like what we are talking about, like gigabyte of like the Parquet file that we mentioned. Like you can visualize it easily. But right now for this lecture, we haven't gone that far yet. So just going to show you how to visualize some small data set so that you can at least take a quick look of what the data looks like. And please quickly, still installing. I think at the end of this lecture, we also have some of those examples. Okay, all done. We start, and let's go here. So you can either create vector data or you can just load existing vector data into the database and you can visualize that. What happened? Yeah, so it doesn't work. So let me remove this one. Hit. It's override. I mean, to have similar behavior, but okay, now it works. And run this one, run this one. Okay, so now you see here we have this geometry and see if it works. If it doesn't, don't blame me. Okay, nice. You see the point? The polygon right in here, right? And also the point is like what we created earlier, right? If you have a mouse, this one doesn't work. But there should be a line. Where's the line? In here? Oh, there's a hole in here, right? The polygon. So this is how it's being done. But at least you can see clearly, right? The coordinates based on these points, lines, polygon, and also polygon with hole. Right, so if you want to visualize, you can just read the vector data and then convert to GDF, and then you can just use the GDF.explore. Yes? Oh, did you hear this one? Oh, this is XY. It's longitude, latitude. Longitude, latitude. So if you see from, for example, here, right? The first point is 140. So this is roughly the center of the US. And also this one. So all those are basically longitude, latitude. And that's why you see 0, 0, right? It's by near the equator, right? 0 degree. Where is this? Yeah, this is near 0 degree here, right? It's near the center. This is 0, 0. And then 1 and 1. So this is how you visualize data. You of course can use Gmap, leaf map to just add the geo data frame if you want to. But okay, so this is how we create data from scratch. and then get the data out from the database, and then we visualize that. But if you want to, you can also similar in here. So now we have this samples table. We can select and then convert these ones to text, right? So again, this function is quite useful, especially if you want to get the data out as a pandas data frame. Most likely you want to use this function. Otherwise, sometimes it can be just binary data that it cannot understand what is this. So what we're doing here is just select the point where name equal to point, right? So if you go back to this one here, so right now we have we have 2 columns. So we're going to select all the points, right? You can select all the lines, select whatever. So you can actually visualize multiple data type together, right? So here, now we have 2 points, right, in there. So this is doing the filtering. And similarly, you can also use this one, st_x, st_y. So you can think about this is DuckDB database is more like vectorized. What does that mean is it's going to do that for all the rows. So what we're doing here, because we have the geometry column, and we want to get the x as one column and get the y as another column. So again, if you go to the extension here, you go now, I think here, stx here. So you can pass in a geometry, it's going to return you the x. So what this one is doing is, so earlier we have one column and it's point, right, x and y, but you say, okay, I want to split that column into 2 columns. I want to have the x column, I want to have the y column, or I want to have the latitude column, I want to have the longitude column. You see? Right? So this is easy, you can split. And if you don't like the name, this is what you can do, right? So select blah blah. I can say as, is there some longitude or latitude? X longitude, okay, longitude, okay, and then this one is latitude, okay, whatever name you like. It doesn't have to be exactly the same, but now I can convert it. So you can think about this can be like, imagine that, okay, I have a point shape file. Right now you want to convert it to a CSV, but you also want to keep the longitude and latitude a separate column. Then you need to use this way. Make sense? Or you can have line, you can have whatever. This is so handy because otherwise you need to use GIS, need to like calculate geometry and get one column, calculate the other geometry, get y. But this is just one line, and then you can do whatever you want. So you can extract the coordinates from that if you want to. And similar this one here, right? I loaded the data. So this one has 491 rows, right? I have the column in here, x and y. So similar here. If you want to like extract the information, for example, this geometry column, you want to create the longitude latitude, you can do that as well, right? So all I need to do here is select from blah blah blah, and I can say select star. I think exclude exclude geometry, GOM. Okay, make sure you remember the name. So right now I exclude what, GEOM. Okay, GEOM. Okay, so here right now I have this table. I excluded the geometry, but I want the geometry as separate columns. I want the x and y. So what we can do here, you'll be st, right? What's the name? X and y, right? Come here. It's the same as this one. st and then underscore x, and then GOM. Okay, xt underscore y, GOM. Make sense? So what I'm trying to do is, okay, I want to keep all the columns. I don't want the geometry column is like point something. I want just the coordinates. And look at this. How nice. So now I have this x and y. And of course, you can just rename it. I say I want to rename it as long. And this one is lat. See? It's done. So now you can export this one as a CSV. So you have that column as points, rather than it's like a single string. So those are the functionalities is pretty useful. Or you can convert them all at once, like it's a string. This is pretty much the same if you directly display. So again, xt as text, that one is quite handy. As y as x, it's also something might be useful you want to use. And similarly, you can do like line string. It's going to print out like this. You can also calculate the length. So if you have ever in ArcGIS or QGIS, how do you calculate the length of a line for all the lines, all the records in your shape file? Can you do that? No. You don't want to like I have 1,000 lines. Do you want to measure all the lines? Uh-huh. Right? You remember calculate geometry and then create a new column and then calculate length. But you can do the same thing here. So remember, so this line, or is this the line? Oh, this is not the line. So I can show you here how to actually calculate the line for all the lines. Let me quickly show you. Okay. So in the table, there's a NYC street. Okay, show you here on top table. Okay, NYC, oops, NYC street. So that database has a vector data with this kind of line string, right? All the lines. I will show you how to visualize later. But for now, they say, okay, I want to add a column with length. Calculate the length of each line. Then you can use QGIS, ArcGIS, or you can just use the DuckDB. You know? So what you do here, select ST length and make sure you know the name here. It's called GOM, and then from okay NYC street. Okay, I don't need the last line because I'm calculating this vector data, and let's see if it works. I hope it works. Okay, see how quick it is. If you use GIS, I guess you want to run like it's not going to this fast. This is super fast. So I think I show you like how many columns, what the line, the length of each column. I can certainly do here. I can say select X and then exclude GOM and then this. So now I can have both. Oops, GEOM. Right. So now I not only have those rows, I also have the length of all the lines. I will show you how to visualize that later. But for now, right, simple and easy. You can calculate a line, you can calculate the area. It's just that simple. For the polygons, I can calculate the polygon. So similarly, right, these are all the polygons. You can calculate the area, st underscore area, and you just run it. Okay, and you can also do collection. So there are multi points, multi line, multi polygon geometry collection, something like that. Right. And lastly, data visualization. I can quickly go through this one. We don't have time yet, but I think I need to update the package leaf map. This one is probably not the most updated, so you need to make sure they update to the latest version. I just released this one midnight last night, so I added it, so now it's easier to visualize. I'm going to just update leaf map so that you can quickly see the content. We'll cover that again in another lecture, show you how to visualize like gigabyte of data, vector data. For now, this is the simple way you can do that is to read it as a data frame and then convert it into a geodata frame. So what we are doing here, right? We have all this table. I'm going to select blah blah, and then this is converted into a data frame, and then I show you the contents, right? So in here, scroll to the right. There is this column here. This geometry column shows you all the points, and in order to be able to, you can convert the data frame to geometry. So just call the leaf map function data frame to GDF, so to geodata frame, and then just tell it what's the coordinate. So these coordinates are in the UTM-18, so it's EPSG, this one, blah, blah. Again, we'll cover that next time. I'm just going to quickly show you. So in order to be able to visualize, we need to use the GCS 4386. Oh, yeah, you need to restart a column. That's annoying. Let me quickly show you. So it will always be nice to be able to visualize the data. Otherwise, it's like, okay, we can get the table, so what? So this is basically something you might want to do. You can visualize a small sample data set. So most of the time, if you already have the data in there, you can convert it into the data frame. I have to happen. We're running out of time. It's not working yet. Okay, good here. Hold on. Hopefully it works now. Come on. Okay. So now we have this. This is a geo data frame now. So you can see you have the geometry, and then you can just use explore. See? Now I can see all the points. Nice, right? You can see the line, you can see the point and something. So the workflow is like this. You have the database, you filter the data, and then you just stock df to get the data frame. But if you already have the geometry column in there, you can convert the data frame from plain text to geometry, and then you just gdf.export. So just go through that. You will be understand. So the key is here to use the leaf map to do the automatic conversion. And this is just the point. I can also do the line like NYC street. I get this, convert this one to text, and then get the data frame, and then display it. This is plain text. This one is not geometry. But if you call this function, and then you will turn into a geometry. Right. So now this one here, you will see the coordinates converted from this number. This is UTM-18. So the original coordinate system are now converted to longitude latitude, and then you can explore it. So this one are all the street in NYC, and you see here it's pretty slow. And if you have the last data set, it's going to be not very responsive. So you need to pay it. You see, it works. But in a future lecture, we're going to cover how you can visualize like gigabytes. It's also very fast. But at least right now you can see all the lines, right? Make sense? So database to data frame to geo data frame, and then visualize. Okay, small one like this, large one we cover in another lecture. Okay, so that's all for today, and the next will be the quiz.